Pleasant good morning to everyone, and we thank you very much for the nice gathering done by ITF team and giving an opportunity for us to discuss the subject of importance of technical services and audit for achieving the productivity and quality in spinning. Mr. Bhaskar was continuously interacting with the speaker. All my friends and seniors were all there, participants were all well experienced, and the session should not be very theoretical and it should be more practical. So I just tried with all our experience and tried to cover up the best what we can give to the industries. This topic we have divided into major three parts. One is to tell about LMW, what service we have. That is the about 4, 5, 6 slides we will cover. Then next comes to what is the benefits we can do or we can make profit through services for a spinning mill. So namely I just want to cover up in the three topics of spinning mill. One is the project management, how LMW is doing it for a new spinning executions. And second is the technological support, what we can do, especially for customer complaint, how we get involved and make the move forward. That is the second topic. And third topic is the machinery health assessment by service, by maintaining the machines. What is the profitability we can do it for the spinning industries. This is the major three topics. All these three topics, we got experience with our team, service team. We got a case studies, about 6 case studies is a very practical case studies. We will be discussing it. And also I would like to say, we will be little more interactive rather than only I give lecture and then listening it. Let us make we are all seniors and then we are all day to day working, and this is purely before my colleagues were all different management session. This is a technical sessions. So let us I just thought about the LMW. What is the, as you are aware, we make from blow room to, earlier was spinning, now we have started making up the auto corner, and we have supplied about 40 million spindles in India as well as all over the world. We got a widespread 15 countries, and we have factory locations both in India as well as China. And our business is into 4 categories. One is foundry division, textile machinery divisions, machine tool divisions, and advanced technology center. And this is the global presence. We have a sales and service office, countries like Vietnam, Turkey, Bangladesh, Thailand, Africa. And India, we have about 254 engineers spread across 11 places, and we have a service setup at LMW Global Service, and other areas we have channel partners, Voltas, SSIL. It is spread across all the places. And we also have a technical support center at LMW. This is mainly for interacting with the customers. We have a contact numbers. The customers can reach us directly and then get the clarifications on the electrical troubleshooting, mechanical troubleshootings, any queries on the spares. This facility is available, and we also extended the timing from morning 8 to night 8 o'clock. It is available actually. And then we also got an electronic repair service center, which is at LMW, and we have a computerized control test equipments, and we are using a genuine spare parts, and it is a 6 months warranty also we are using it. These are all the parts like gear motors, PLCs, inverters, drives, all those things can be repaired at our end. Similarly, we have a service setup for mechanical also. The consumable items like beaters, nippers, cyclodrive, full width grinding roller, all those things can be serviced. And we have a training center equipped with a special classroom. We have different programs starting from foreman level to management levels. So these are all the things we have explained. We have seen the slides with the LMW, what the service network we have. Now coming to the topic, the spinning mill, what challenges we are facing it. If we go through the slides, raw material price is getting fluctuated. Availability is also a big constraint. Power, lack of manpower, skill set, competitivity of price, delivery commitment, customers complaint, what customer is expecting. That is, if you give it to a weaver, what weaver is expecting. If you give it to a cloth manufacturer, what is his expectations. With this, we have to do the modernizations and then utilizations, special process, technology assistance. These are all the real challenges which the spinning mill is facing. It is a cyclic action. Every time we face these problems. Now, as a machinery manufacturer, what role we can do and what support we can do? Except raw material and power, of course the delivery commitment, all other aspects, whatever we have discussed, LMW is playing a major role. Through service, we can do the best job. So the role of technical service, as we were discussing it, we are divided into three parts. One is the project planning and executions. This is applicable for the new mills where the projects are being executed. What support is we will give from LMW. And another is technology partnerships for productivity and quality. That is optimization of process, better raw material management, customer complaint. This is a special focus team we have. We can support for the customer to obtain this, resolve these technological issues. And then next comes to maintenance system, machinery health audit. That is, check and review the present system, identify the gap, improvement plan, and also implement the performance kits. So these are all the three topics which we are going to discuss in depth. So for project management process layout. We see the slide. Actually, it is covering stage 1, stage 2, stage 3, stage 4. As we were discussing, we have engineers, have 250 engineers we have. We have a group of technological team, project execution team, as well as troubleshooters. Like that, we have different classifications. Now, if we see these slides, what LMW supports from layout, the first comes from layout, and then goes up to the post-installation and handing over the projects. So the first one, stage 1, is the documentation. We give the technical data sheets and facilities required for the machines, and then powers, accessories, and then machine live, including the spin plan. What is the production we need to commit it, how much we have to do it up. If you see the spin plan, earlier the spin plan is only for forecasting the production and quality production, and it may change in the market scenario. But now current trend, whatever, when I joined, the spin plan is only an imaginary. But now the spin plan is a real execution, and then we need to take while handing over the project. That was the trend has been changed. So we give this stage 1 with the documentation, and then stage 2, we have a site meeting. We call it a site meeting. That is, we take care of the civil process, what is the trench sizes related to machineries. What the trench, how you made it, what is the depth, what are all the facilities required for the floor, what is the floor level variations. All those things we will also inspect and then make it sure that this is not went wrong before the start of the executions. Similarly, as you are aware, in the spinning mill, there are two major categories which plays a major role. One is the communication plant and another is the filter room. If we make any mistakes in the calculation of the filter room or communication plant, then we will have a future trouble, and this becomes permanent error in the spinning mill. We cannot even correct it afterwards. It's very difficult. So we involve from the beginning with the supplier and then work out what is the plant size, what is the number of air changes it is required, and then filter room, what is the volume they are given it, whether it is sufficient, any additional machines we have to get up. So our team, we are well experienced and we get involved in the projects in the initial stage itself, so that while buying the order, placing the order itself, we will get the very clarity, yes, this is what we are going to do. So we will forecast. Similarly, stage 3. Stage 3 is nothing but the documentation, whatever we are given, we will verify it, the reality actually. That is the recommendation of the pipeline, how it is went, what are all the pipelines is being given, and also power accessories. And also, we also plan for the manpower installations. That is how many manpower we need for installations. So we will, prior to erection, we will tell them what is the manpower is needed. Similarly, we will also tell them unloading facilities, what facilities you need it. So these are all, forecasted, and then we will guide them well in advance. Then during project executions, we have a project leader, very well experienced. He will have erection team members, and then the erection will be executed as per the chart, commission it, process stabilization, and also we also give the on-site training. So this is the total setup. If you see it, we make the partnership from the civil, fumigation plant, and then compressed air, accessories, so that this execution goes first time right. That was the concept we making in the project executions. Then next comes to, we have also developed a new concept that is called technological partnership. It is earlier when we see it, we sell the yarn based on that IPI or the CSP. These are all the two categories which normally look it up. Now, if we current scenario, it is not only looking on the quality of only testing instrument. We have to go and see what is the end use of the yarn. That is what the challenges are faced in the recent scenarios. We also have some examples how we attended the customer complaint. When you sell the yarn may be not running in the working yarn, or the yarn may not give, the fabric is having thick places, or the knitted cloth is having thin places. So these are all the challenges, not only in India, even abroad, we are facing it. And we have a specialized technological team, and we have a lot of techniques how to handle it and then resolve these issues. I will explain you in the last topic what are the real case studies what we attended by our team, and then we can interact it. Then next comes to machinery health audit. This is the, we also recent days we are also started doing for ITF customers, and earlier also last 10-15 years we are doing this exercise. Now the question comes, why we need an audit? Audit, what are the planned maintenance? What areas we are working and what areas could be improved. There is a continuous improvement is definitely is available, that we have to locate it and do it up. If you see the audit process, it's divided into four parts. One is machinery health conditions and technology, electrical and performance enhancement kit. In the health audit system, we have to find out what is the deviations in the maintenance and settings or practices. And we have, our team has got plenty of experience with the different mills. So we will be able to identify and guide you what is the best practices can be employed for a spinning mill. Maybe particular mill we will be doing it with the inside, but all over the world and other places, some mills use the best practices in the settings as well as in the work practices. That can be guided. So this is what we can do. And technology, yes, through service, we can also fine-tune the machineries to maximize the productivity and quality. Everything is possible. And then similarly for electrical, for earthing system as well as safety system, our team is expert and they can guide us. And also the performance kit, what kits it will be suitable for this particular mill, particular process, that also we can exercise and do it up. So if you see the maintenance management system, the left side is our requirement. That is, we have to maximize the productivity with the constant quality and optimum cost. This is what the requirement of the spinning mill, and then only we will make the profit. Now, to these activities, we have to do the maintenance activity, corrective and preventive actions, trials and validations. If we see this bubble, we have to document these operations and then review it up and then again do the corrective and preventive action. It is a cyclic. We should not stop only doing the maintenance and then preventive actions and then stop it up. No, it is a cyclic operations. The review, the input will be given from QA and production. QA person will say, yes, I am not getting the quality. Production will say, yes, I am not getting the production. And store person will say, my input cost is more. And accounts will say, my costing is more. So all this input has to go to a review, and then from there we have to work on the maintenance, this documentation and do it up and obtain this maximum productivity and with the quality and the minimum cost. Here this health audit, this chart, normally in industries, what we do is breakdown maintenance. Whenever the machines break down, yes, we run it up. The breakdown may be due to filter or maybe due to machinery or maybe due to work practice. This gives a lot of loss to the company because we lose time and the person has to go. If it is night shift is happened, then daytime we have to wait, and then the accuracy of the work time, everything is big problem. Now, next maintenance what we do is a preventive maintenance. That is, say for example, card, liquor and wire is to be changed. Yes, we will change the clothing after 150 tons or 200 tons. It is a preventive scheduled maintenance. These two maintenance, many mills are doing it, no doubt, because then only we will be able to run the unit. But if you see the third category, and as well as fourth, third is to physically verify what machines, conditions of the machine. That is the predictive maintenance. That is monitoring with an instrument you have to check it out. What is the condition of this machine? Is it vibrating? Is it having a wear out part? It is giving a more heat. That means it is something like that. We have to check the condition of the machine and then take action. And fourth important is the proactive maintenance. In many mills, many industries, we are not doing this actually. If you truly ask me, we with a lot of work pressure and other things. So this is where our LMW plays a major role, and we will give we will block these areas where there is no need to get this again repeat of this complaint. That is called proactive measurements. This is what we need to concentrate with the maintenance team. Then only this cycle of reactive and then preventive maintenance can be reduced. And this is the chart which many mills reactive maintenance is very high. This last chart, that is the proactive, needs to be improved. And I just we have time is also being given limited. I just run through the case studies, which is very interesting. I just take, madam, 5-10 minutes with your permission, because this exercise is done with a lot of hard work and a lot of time, and I thought I can share this. See, this is the cloth, one of the composite customer. We see it in the cloth, there is a thick place in the cloth. Many of you are aware, this is a small length fault. It is 1 to 2 centimeter length, and it is about 140 to 160% length. And this is one of the export customer, where they got a standard. 15 to 20 parts per 100 kilometers is allowed, and whereas we are getting it very randomly, and it's a big project, and this is the task we are given to us, and the lot is getting rejected. Can you assume what could be the reasons? How to approach it? Any idea? Can you share? Okay. What we did, we checked up our normal standard of blow room cleaning efficiency or drop room percentage. This really thick places means we will concentrate more in the speed frame, ring frame, but we are not able to identify. Unfortunately, the textile, such type of random faults, we don't have instrument. We don't have specific testing which we can really help us. But with a lot of our team has put a lot of effort and then identified what is the measure first we have to do it. Because visual observation is always difficult. Somebody will say this cloth thick is more, or somebody will say no, it's okay. But we identified the root cause, and I just tell you the technique what we did. We have measured the yarn body in the Euster classmate. This mill is equipped with Euster quantum. We have taken the classmate mass diagram, how it goes. If you see the diagram, where this B1 fault, it is rounded to the left side. This is bulging actually. That means the body is the yarn structure and the top of thing is the variation of the fault. That was counted by the sensor and it is accumulated for a full length, which is normally tested in the IPA or other tests. So we have captured this as a measuring instrument and then try to attempt this problem. If you see, it's interestingly, this was the reasons identified. There was a beautiful arrangement. Now earlier, we used to check, the seniors has all taught me that drop frame is the final end product, which should be checked up. If any problem comes, afterwards we cannot correct it. This particular case, the drop frame, we have a stop motion called thick places. That is, any material which goes to the thick places, it can be measured and then stopped. But this particular case, they have switched off the stop motion. So the faults was going on. The combers were producing little rogue cants because it is connected with about 40 combers. The rogue slivers were coming randomly and then it goes. So we switched on the stop motion. Then the sliver at the comber stage, drop frame stage, comb sliver has been stopped up. Then we identify the reasons. There are some pressure in the top roller, pressure in the top, detaching roller was high. So the web selvages was getting damaged. So all these small problems, and randomly it was coming up. So we have corrected this process. And then if you see the classmate also, earlier the classmates was about, cut was 110, then it was reduced to 60, as well as the B1 fault was ranging from 53 to 30. So this is one of the exercise we did it with one of the leading mill, and then we resolved the issues, and then of course we have also continuously monitored. So this is the fabric before and after. Then another case, interesting study, how to improve the waste, yarn realization by optimizing the waste. This is another case study which we have got interestingly. Normally what we do, blow room card waste means we will just reduce the waste and then the blow room will reduce as well as the card will reduce. This is a technique, generally we do it up and look the fiber whether the lignin is having a white waste or. But this particular case, if we see it up, before it was about 11%. This is a little MP bunny mixing. It was about 3.5 to 4%. So the total waste is slightly higher compared to the normal standard. Afterwards, we reduced to 10. Now you can ask me what technique we adopted it. This is an interesting technique which you can also try it in your mill. We increase the blow room waste. Normally the blow room waste, we should not reduce it up. At least, especially the first beating point, we should increase it up. This is one technique adopted. And another is card, we have increased it. Now, this is a general, yes, everybody can increase it up. But here we applied one beautiful technique. This you can try it up. This is the work we did it. What we did, we have taken the material of each carding material. That is the feed roller waste, lignin waste or first lignin, third lignin. Individual waste has been collected and put it in the office. Then if you see the results here, the office results was giving 29 mm UPL fiber length was going in the waste. So this is the key area identified. Yes, this is the white waste which is going in the feed roller zone as well as in the third lignin zone. So this is a scientific method, one can try it out. Yes, card waste can be analyzed through office or Celly analyzer. And you use office, there will be some restrictions, there will be choking, and then there will be some problem will come, but we can clean it up and then try it up. But this mill was giving the opportunities, and we have identified the real lint loss, how much it is there in the waste. Then only that lint we have reduced it, and then we have matched the saliva results and the yarn results. So this is the beautiful technique available in the industries. But fortunately or unfortunately, due to the busy schedules, we are not able to go in depth. I just tell you, any spinning industries, if you go to a carding machine or a comber machine, between cards, you will have waste variations. Between comber, you will have waste variations. and definitely you will have a lint loss in the fibers. I am 100% sure. Earlier our seniors all thought it should be 25% lint loss, 30% lint loss. Now not like that. The lint loss has to be, the minimum, as minimum possible, then only the industry will survive. I went to Turkey, where we thought Turkey is a very good country where they will lavishly give the lint loss and all. No, it is not so. They are much more stringent than us. They are not even allowing 5 to 10% in the lint loss. I was working for only for the boring droppings for about 6 months to reduce it to 2%, 3%. And this is the standard they maintain for the European markets actually. So but whereas in our industries there is a scope. And especially for carding machine, the flat zone, what we are doing is we are not exporting the 100% utility of the flat zone. I have my own personal experience as well as my colleagues have done a lot of exercise. We are not exporting, especially the flat cylinder, I repeat again. The flat gauge variations will be there, between flat gauge variation will be there, and we are keeping the gauges. Front we have to close the gauge, back we should open the gauge. Please try this exercise, definitely you will get the waste saving. If you give it close at the bag itself, the fiber entry, fats entry you will lose lot of good fibers. This is practically we have seen it in many mills. So please try with this input, and I am 100% sure overall come with the technicians, and definitely there will be a scope in the waste saving. And here we have just calculated out for 24,000 spindles, it works out about 40 lakhs. I just go with the critical case studies because of the time. Warping brakes are more, one of the mills. This is another composite mill, big mill. They are given a complaint. The warping brakes was 7 to 9 brakes per 10 million against the requirement of 4 to 5. Now this is another challenge we have given to us, how to solve it. We see it, the mills, along with the mills, our technological team has worked out. If you see it, we have normally when warping brakes means we will go and check with the TPA variations and then CSB, strength of the yarn. Yes, we did all those things. Nothing has come out. In fact, the mixing, the mills has changed the mixing. DCH, they have increased the mixing percentage. Let us increase it so that this problem can be resolved. But we are not able to identify. This is a compact yarn. We applied a technique of RKM, minimum RKM where the yarn is got low. We use the TensorJet and then identify where the yarn is having a minimum RKM. And then if you see it, it's a simple mistake, but it has went to the very major fault. That is, the aprons were not cleaned in time. This is a compact apron. So it is get choked, it is get blocked. Then subsequently it is resulted into a warping brakes. So gentlemen, please note that these are all very, very practical studies which our team has worked very hard and then we are sharing it. And then similarly for traveler life, how to find out the traveler, how to select the traveler life. These are all small examples, just I would like to give it up. Traveler has to be inspected and we got a lot of profiles. Depending upon the count, depending upon the speeds, depending upon the material, one can select it. And if you have a right selection of the traveler, definitely you will have end breakage rate and probability of the spinning mill will increase. And similarly, in the recent ITF study, we went for an audit. This is an audit exercise. One of the cases where the feed roller lapping was very high in the FlexiClean machines. They have also tried with different settings, and finally we resolved with the installing with an STUD arrangement where this air was giving a turbulence in the FlexiClean, and then we have resolved it. I just go with the final kits of energy kits. My next speakers were talking about energy. I just want to give kits what's available at LMW so that it will be more useful to our industries. We have developed the success in fan motors. Here the fan motor with the fixed speed it will be running 5 kW or 6 kW type. Now we went for a closed loop with the pressure transducer. We measure the pressure and then the fan will put the display with the inverter. The fan speed will get varied. Now question will come. Once the speed is reduced, then the overall manually the fans will get changed by loading. So this is the beautiful concept which we have derived, and then we are to see what is the benefits we got. It is the units per day now the mill that gets ready to stop. Because about 21 units is got saved, and the cost of it is about 29,000, and if you work out the ROI it is about 14 months. This is the highest period I have given as a serviceman. I have looked only the highest reading. But if you see in reality, it was even going up to 45 units saving in the machine. It changes from 6 months to 14 months, and then this kit was moving very fast, and this kit you can try it for all models of machines, LR6, LR6S, and then also LR60 and also LRJ9. Similarly, we also developed an opti main motor. This is a new technology concept. This is where the motor runs with a lesser magnetic loss. Here also we got about saving of 4 to 5% savings of that. This is a trial we have conducted. So thank you, gentlemen. I just made some useful presentation to you.